Hello everyone! This video is entitled Writing and Naming Ionic Compounds. In this lecture, I will provide the framework for writing out the chemical formulas of ionic compounds from their given names, and outline the procedure for naming an ionic compound displayed to you as a chemical formula. If you have not yet watched my video on ionic bonding, it is recommended that you do so first to fully understand this material. You can find a link to that video in the description below. Okay, let's get started.
Every compound on Earth has a chemical formula and a particular chemical name. That chemical name needs to be recognized worldwide in order to effectively communicate chemistry across borders. The International Union of Pure and Applied Chemistry, also known as IUPAC, is the universally recognized authority on chemical nomenclature and terminology. IUPAC develops recommendations to establish consistent scientific nomenclature and terminology to be used worldwide. Naming rules have been developed to ensure all compounds are named consistently and, of course, every chemical formula written out identically. The names that are based on the IUPAC rules are called systematic names. Names used by the general public that do not follow IUPAC guidelines are called common names. We will be focusing on the systematic names of compounds, those outlined by IUPAC. Now, before we jump into naming, let's review ionization and the formation of anions and cations. So, as I mentioned in previous lectures, an element will react based on the number of electrons it has in its outermost energy level. This is called its valence shell. Each element loses or gains electrons to achieve a stable electron arrangement, known as a full octet. And so the elements that belong to the 8 primary groups on the periodic table are all considered stable when they have a total of 8 electrons in their outermost energy level. This is, of course, due to the fact that these elements abide by the octet rule. Chemical bonds form between two atoms when the electrons in their outer valence shells become situated into stable electron arrangements. Take, for example, a bond between sodium and chlorine. Sodium has 1 electron to lose, and chlorine requires 1 electron. And so these two elements, when they come together to bond, that bond will be incredibly strong, because a stable electron arrangement is created in both elements. When an atom gains or loses electrons, it becomes an electrically charged particle called an ion. The process through which an atom becomes an ion is called ionization. And so ionization is the process of an atom gaining or losing an electron. It's incredibly important to take note here that when an element gains or loses an electron, it is no longer considered an atom, it is considered an ion. Atoms are neutral particles, and so we only describe elements as atoms when they are neutral. As soon as they become charged, we call them ions. When a neutral atom loses an electron, it becomes a positively charged ion, called a cation. When a neutral atom gains an electron, it becomes a negatively charged ion, called an anion. An atom can only lose an electron if there's an atom nearby that is able to gain one, or vice versa. You got to bear in mind that an atom will only lose 1 electron or several electrons if there's an atom nearby that is willing to take those electrons. In an ionic compound, the cation will have the original name of the metal element. However, anions always have an altered ending, and so an anion is named according to the element that formed it, but the ending of the anion is changed to "ide." So if you take chlorine, for instance, its element symbol is Cl. Now, its anion name is chloride, and its symbol is Cl1 negative. And of course, the charge is based on its position on the periodic table. The element oxygen has the element symbol O. Its anion is called oxide, and it is symbolized by O2 negative. Phosphorus, symbolized by P. Its anion name is phosphide, and its symbol as an anion is P3 negative. And bromine, symbol Br, anion name is bromide, and its symbol as an anion is Br1 negative. Now, to write the chemical formula of an ionic compound, for which you have the chemical name, you must use the crossover rule. Unfortunately, the rule cannot be easily described, and so you will see how it works in just a second. But before we get to that, you should note that the process of writing out the chemical formula can be broken down into 7 simple steps. Let's apply these steps to sodium chloride. First, identify the metal and nonmetal in the ionic compound. And so clearly sodium is the metal and chlorine is the nonmetal based on the positioning of these elements on the periodic table. Second, write the symbols. So we know that the symbol for sodium is Na and the symbol for chlorine is Cl from the periodic table. Write the charges. Again, based on the positioning of these elements on the periodic table, I can infer that the charge on sodium will be 1 positive and the charge on chlorine will be 1 negative. Number 4, cross over the charges from top to bottom. And so this is the crossover rule. What the rule states is that the charge of one element should be crossed to the base of the other element. And so sodium's charge will be crossed over to the base of chlorine, and chlorine's charge will be crossed over to the base of sodium. Let's see this in action. And so you can see that the charge of sodium now is at the base of chlorine, and the charge of chlorine is now at the base of sodium. Step 5, remove the charges. And so you remove the positive and negative sign. Step 6, simplify the numbers and remove the ones. And so we have 2 ones here that we can easily remove. Step 7, write the chemical formula. And so all you do now is put the 2 symbols together. What the crossover rule has helped us to determine is the number of atoms from each element required to come together to form a chemical bond. By crossing down the charges of each element, we essentially now have an easy way of determining the number of atoms required for a chemical formula. Now, the reason why 1 sodium and 1 chlorine atom are required for this compound is that sodium has 1 electron in its outer valence shell, while chlorine has 7. And so chlorine, of course, needs that 1 electron, and sodium needs to lose that 1 electron, and so that is exactly what will happen. When that electron is transferred, sodium now develops a 1 positive charge, and chlorine develops a 1 negative charge. And of course, opposites attract, creating this compound. Let's do a few more examples. Here we have calcium oxide. First, we identify the metal and nonmetal. So we know that calcium is the metal and oxygen is the nonmetal. Second, write the symbols. Symbol for calcium is Ca, and the symbol for oxygen is O. Now write the charges. From their positioning on the periodic table, I know that calcium will be 2 positive and oxygen will be 2 negative. Cross over the charges. So I'm going to bring down the 2 charges. Next step, remove the charges. So I'm going to remove positive and negative signs. Now I'm going to simplify and remove the ones. And so because both these numbers are 2, I can divide them both by a common multiple of 2, and I now have 2 ones. I then remove the ones by following this step. Now I'm going to write the chemical formula. So now I just simply put what I have left together. And so calcium oxide is chemically written as CaO. So why is it that we only need one calcium atom and one oxygen atom to form this compound? Well, we know that calcium has 2 electrons in its outer valence shell, and oxygen has 6. And so, remember, the metals are going to lose electrons to the nonmetals. So calcium is going to lose its first electron to oxygen, and then its second. And so now you can see that both of these atoms are stabilized. Calcium now exposing its inner shell as the full octet, and oxygen now having a full octet in its valence shell. We have 2 ions, one with a positive charge and one with a negative charge, that will attract each other and form a compound. Let's write the chemical formula for magnesium chloride. First, identify the metal and nonmetal. So we know that the metal is magnesium and the nonmetal is chlorine. Write the symbols. The symbol for magnesium is Mg. The symbol for chlorine is Cl. Write the charges. Again, based on the positioning of these elements on the periodic table, we know that the charge for magnesium will be 2 positive and the charge for chlorine will be 1 negative. Cross the charges over from top to bottom. Remove the charge symbols. Now, simplify the numbers and remove the ones. We can't simplify these numbers any further, but there is a 1 at the base of magnesium that we can remove. Now write the chemical formula. Take what's remaining and put it together. Let's see how this compound forms. Here we have 1 atom of magnesium and 1 atom of chlorine. We know that magnesium will have 2 electrons in its outer shell, and chlorine has 7. Now, if that chlorine were to take 1 electron from magnesium, it would become stabilized and have a charge of 1 negative, leaving behind a charge of 1 positive on magnesium. However, magnesium still has 1 electron that it needs to lose to become stable. And so that is why a second chlorine atom is required. That remaining electron will be passed on to the second chlorine atom, creating another chlorine ion, and changing the charge on magnesium to 2 positive. And for our last example, we have calcium phosphide. First, identify the metal and nonmetal. So the metal is calcium and the nonmetal is phosphorus. Second, write the symbols. So the symbol for calcium will be Ca and the symbol for phosphorus will be P. Write the charges. So the charge that calcium develops in a bond is 2 positive and the charge that phosphorus develops is 3 negative. Cross the charges over from top to bottom. Remove the charge symbols. Simplify the numbers and remove the ones. In fact, we can't simplify these numbers any further, and there are no ones to remove. And so, when we write the chemical formula, we put what's remaining together, and we get Ca3P2. And that is the chemical formula for calcium phosphide. On this slide, I've provided some practice questions. The answers to these questions are given to you in the slide. I strongly recommend that you try your hand at these questions and make sure that you're doing them correctly by referring to the answers. And with that, we arrive to the naming of ionic compounds. An ionic compound always has the name of the cation followed by the name of the anion. The cation in a compound will have the same name as the metal element, while the anion will have its elemental name with the ending changed to "ide." The example I have here is the chemical formula Be3N2. Now we know Be stands for the element beryllium. We know that N stands for the element nitrogen. Now because beryllium is a metal, it will definitely be the cation in this compound. So that's written first. And nitrogen being the anion will take the ending "ide." And so put together, the chemical name is beryllium nitride. So obviously you can see that the writing of chemical names is much easier than the writing of chemical formulas. Here I've provided you with some practice questions, and as always, I've given you the answers to those questions within the slide. Strongly recommend you try your hand at these questions and refer to these answers. And with this slide, I conclude this package and this lecture. Thank you for listening. All the best.